Okay, my friends, next up, read this last little bit of our last study, straight out of Greece, about secondhand smoke and its effect on lung function. And now that I'm looking at it, you could probably just hit pause on the video right now, and that's the entire thing you have to read right there in the window. So go ahead and read it, and then we'll analyze. Okay, so now you've had a chance to look at it. Some things that might have jumped out at you. There's probably some words that don't make sense. I had to Google what cytokine was. I'm not even sure I'm saying it right. Something else that may have jumped out at you is the fact that it's a very, very small data set, 16 non-smoking adults right there. But we're here not to analyze research methods, but to analyze the conclusions, which are down here. And I see two p-values. I see one that's less than 5%, and I see one that is greater than 5%. As a matter of fact, there's actually two that are less than 5% and one that's bigger than 5%. Let's get into that next. Okay, my friends, so here is what I want to focus on right now. This is the hypothesis testing conclusion part that I want to take a look at. It looks like they tested two different time frames. They tested from 0 to 1 hour, which was when I guess they put the people in the room with the smoke exposure. And then they took them out of the room at 1 hour and then tested them again at 3 hours. And they came up with two conclusions. From 0 to 1 hour, it looks like function parameters were significantly reduced, but at 3 hours, they were back to baseline. So let's take a look at each of these. All right, so first, 0 to 1 hour, time of initial secondhand smoke exposure. Most lung function parameters were significantly reduced. What supports that belief? This p-value right here, less than 5%. So p being less than 5%, implying that lung function parameters were reduced, must mean they started with the null hypothesis that they wouldn't reduce it. In other words, they started with the belief that secondhand smoke has no negative effect on lung function. Now that might not sit well with you. I mean, you and I both know that secondhand smoke in general, bringing smoke into your lungs, is bad for you. But that's only because we have the benefit of the last 50 years of science. There's no reason to think anything has an effect on anything else until you can show that it does. So you start by assuming it doesn't, and then you work to see if it does have said negative effect. So here are the two hypotheses that these Greek researchers started up. Null hypothesis, secondhand smoke has no negative effect on lung function. Research hypothesis, it does have a negative effect on lung function. What does the p-value tell us to believe? It tells us to believe the research hypothesis because it's less than 5%. Remember, the null hypothesis has a 95% confidence interval around it. If we get data that escapes that 95% confidence interval, that means we have statistically significant evidence to believe the research hypothesis that secondhand smoke does indeed have a negative effect on lung function. So does it appear that secondhand smoke negatively affects lung function in that first hour? Yes, it does. Okay, now let's look at what happened when they pulled them out of that smoky room. So now we're going to yank them out at 1 hour. We're going to let them sit in clean air and let their lungs kind of do their thing. At 3 hours, lung function parameters were at baseline level. Now, it's the same two hypotheses, but after 3 hours, we've returned to baseline, which means we believe that at 3 hours, secondhand smoke has no negative effect. And how do we know to believe that secondhand smoke has no negative effect at 3 hours? Because of that p-value right there. Greater than 5% means we have not escaped the 95% confidence interval around the null hypothesis. So at 3 hours, does secondhand smoke appear to negatively affect lung function? No, not at 3 hours. It appears we're back to baseline. As an anecdotal aside, this is one of many studies that were done to show that secondhand smoke was indeed detrimental cumulatively to human lungs. And personally, I moved to Central Oregon with my wife in 2004, and I play drums. And back in 2004, all the way through, 2010, you could still smoke in bars in Bend, Oregon. And I used to play shows on Fridays and Saturday nights, play for a couple hours, and then I would go home and just hack just hack all that garbage out of my lungs. And it was amazing to me because on the East Coast where I'm from, smoking was banned back in the 90s. And moving out here in 2004 and realizing you can still smoke inside, that's kind of weird. Thankfully, studies like this Greek one exist and are done in numbers enough to demonstrate that, yeah, by the way, smoking is really bad for you. And that's kind of the point of statistics. It's to try to see if something appears to have an effect. Now, can we be wrong with the conclusions? With secondhand smoke? No. But in general, yes. Let's take a look at that next.